Now we could also include our endpoints as local maximum or minimum because this is a closed interval. So I should squeeze in a -4 over here. And add in the 4 over here. We're going down, so that would be so that would be a minimum at the end. Now we also want to look at the points of inflection of this. Okay, I'm going to go back and erase this. And for points of inflection, we need to consider the derivative of this. For my derivative then, notice that we are decreasing and increasing. So my derivative is going to be negative, 0, and then positive. Right here, it does not exist. There's no derivative here. It's not going to be one of our vertical tangents because this is just a jump. This is going to be a corner. There's a sharp turn from a positive derivative to a negative. So there's not going to be a point of inflection there. Now we're increasing all along here. So that's all positive. So that's another reason it's not an inflection point. From this point, we're going from positive to negative. Could be an inflection point, except this is a sharp turn. This is not an infinite discontinuity here. This is going to be a sudden change. This is giving us a corner here. So again, this does not exist. This is not an inflection point. So the only place that we're getting an inflection point is right here. So inflection at x equals -2. Let's kind of mark that in there. And we've got a lot of things going on here. Maximum at -4, minimum, well, wait. That's not right. We are decreasing from there to maximum, positive. That's right, so we're increasing. This -4 should have been a negative, I'm sorry. I mean a minimum. Because we're increasing from there. So as an endpoint, it would be a minimum. Sorry about that. And we increase from there. 3 is a maximum. And then it starts to curve down, but we get an inflection point here at 2. We're going to get another minimum at -1, so it's going to curve and then keeps going up to 0. But at 0, we don't get an inflection point. We have a sudden jump from positive to negative. Also, and so we're going to get a corner there. We're now decreasing, and our concavity is still up. Okay, let me draw that a little better. We're curving up, and then our concavity changes, but we're still, our concavity doesn't change. It's still positive. It's still curving up. Then at 1 here, still curving up, but we're getting a minimum value until we get to 2. Again, at 2, we get a corner because of this jump here, that derivative, first derivative not existing. But we do change concavity there. I have to be curving down from there, so my point is going to curve down like this, and it's going to keep curving down all the way until we get to that 4. And so this is a possible sketch. What's important is our concavity. We're negative, so we're concave down from -4 to 2. We're positive, so we're concave up and we're concave up. Okay, something weird was happening here, so we have to get the corner. And then over here, we're always concave down. But we are decreasing because of the first derivative. Okay, so looking at this table, they've broken it up so we've got f prime and f double prime. They're giving us all of our possible points of inflection, all our possible critical points. And here's 0 and 2. And then they also tell us what's happening between these. So if we want to find all of our absolute extrema, first of all, there are no endpoints. Extrema can only happen at critical points. Okay, it does not exist, so we have a change in sign there. We do not have a change in sign here. So this is my only extreme. If I'm going up and then down, I have a maximum at x equals 0, but I do not at x equals 2. Points of inflection, I'm going to consider f double prime. Positive, positive, so no matter what happens here, it's not a point of inflection. But here, I do have a tangent line at 0, and I have a sign change, so my inflection point is at x equals 2. They want a possible graph of this. So the important points are at 0 and at 2. Notice they do give us an initial point this time. F of negative 2 is 5. Maybe I should have made it a little higher, but okay, let's do it like that. And f at 4 is 1. So let's go ahead and put those 2 points on there. From that, I just want to connect the dots here. F prime is increasing until we get to 0. So it has to be going up. It's also concave up. So I'm curving up, and then something happens that does not exist. I'm now decreasing, and I'm concave up. So we're getting a curve kind of like that until we get to 2. Notice that it evens out, we get a 0 derivative. And then it's negative again, it's still decreasing, but the concavity changes so that I am curving down now. Okay, so this one we have a derivative of 0, but it does not give us a maximum or minimum. What changes is the concavity there. Okay, here's your homework for the second part. If you have any questions, post them on Edmodo.